Okay. Hello, everyone. We're going to start now. Tim from Rchain is still on his way, but he should be here in a minute. So we're going to kick this off first. First of all, welcome everyone to our second event of the Genesis Talk series with Rchain and Phone today. I see some familiar faces, that's good, some new ones. So welcome everyone. I'm going to introduce you to our company. I'm representing Staking Facilities today. Afterwards, those two guys are going to present Creative Dog, and we give you a short introduction, and after that, we'll start with both projects presenting themselves. So, I'm presenting Staking Facilities. So what are we? We are a consensus infrastructure provider. I see some question marks. So, what the hell is a consensus infrastructure provider? As many of you may know, blockchains and decentralized networks need physical hardware to run on. Those networks are spread all over the world, and different people from different countries run those networks. And what we do at Staking Facilities, we are part of those networks and we run part of those networks. For example, you can see it like that. We run parts of those infrastructures. So, what is our business model, or how do we work? You can separate that basically in three parts. The first one is research and investing. As you may all noticed, last year was the big year for blockchain. The whole space exploded. So there was a heavy fragmentation, wide range of products. So key for us was filter those projects, find the jewels, and work with them. So what we basically do, how do we pick those projects? We ask ourselves some questions and try to answer them as good as we can. So the first one would be, do the team or does the project have a reputable team? Who is on the team? Are they capable of doing what they want to do? The second one would be, is the tech original? So do they have a use case? Are there people who are going to use their projects? And the next one would be, can they execute their vision? That's also really key. Do they have a good roadmap? Is it feasible? And last but not least, do they have a strong economic token model? Is it just a token to raise money, or do they have a real use case for that? So, the second part after we picked our projects is basically running the physical hardware in a Munich-based data center. We use enterprise-grade hardware in that, and our key factors are security, reliability, and performance. The third part, which is also pretty cool, and that's what we're doing here tonight, is build a community around the blockchain thing. So we bring people together, we want to share our insights, we want to update the community about the progress, what is happening, and we want to connect people from different backgrounds with the topic blockchain. So, if you have more questions, our portfolio right now. So that's the projects we're working with right now. As you may know, we hope to work with Foam and Rchain in the future. So some of our projects are not open to the public right now, but if you want to stay up to date, come to us, talk to us. Florian is right in the back. Wolfgang is downstairs. He's also right in the back. So just come to us afterwards in the networking area, talk to us, get in touch with us. We are via our website. We have stakingfacilities.com. Leave a message on our Twitter account or chat with us in our Telegram channel. So that's it from me. Now Robert and Eduardo are going to present Creative Dog.
Okay, thank you very much, Julius. Now we're going to present Creative Dog, but before starting presenting the company, I just want to ask, because I'm curious, how many of you guys know about Creative Dog? Okay, I was expecting more to skip the talk. Okay, Creative Dog is a company builder. What we actually do is we build companies from start to finish. And sometimes this is misleading because people think we're an incubator or accelerator. We're not. We're actually architects and builders of new businesses. We build companies in areas of new technology edges. Also, we actually fight and crack customer problems, and we give positive experience and new businesses. Of course, all this together to try to get new revenue streams for our clients. So, but where are we? What are we doing? Or I already said it, but where are we? We are all across Europe. We are at startup, but we are more than 250 people around Europe. Especially in Munich, we are around 50. Half of the team is here, and half of the team is also in Prague. But now let's get to some numbers and some facts. And Robert?
So in the last 6 years, we interviewed more than 15,000 people and identified more than 5,000 customer insights, pains, and needs. We used those insights to generate more than 2,000 ideas and tested up north of 300 product prototypes in real market situations. And we're also very proud to say that until today, we helped launch 45 MVPs for private investors and big corporations from different sectors such as Skoda, E.ON, or the Metro Group. So now that you know us, you know what we do, you know who we are, you might wonder, okay, Creative Talk, staking facilities, pretty cool companies. But why are they doing this? Why are they hosting such events? And the answer is pretty straightforward. We found common ground in our belief that real blockchain applications on a broader scale are still missing today. We also believe that Munich has a very unique potential to deploy this technology, this disruptive technology, into people's everyday life by creating a blockchain-focused hub in the Bavarian capital. And Eduardo will tell you.
So yeah, how do we do this? How do we bring this technology to life? So basically, we want to enable a new space where we will connect not only corporate, but just businesses, techs, experts, scientists, also for universities, and especially enthusiasts, where we all work together to not just bring, but also deploy this technology to our daily life. Julius?
So the question is, what are we going to do? As Robert already mentioned, we are going to launch together the Genesis Hub. The Genesis Hub is going to be a place where people can connect around the topic blockchains. We want people from different backgrounds, corporates, startups, tech companies, just interested people to come to our place. We want to host events and bring them together around that topic, blockchain. We want to make it easier to get access to it for corporates, try and error, find some ideas, test them, and work around that topic, blockchain. So if you want to get more information, visit our website. It's genesishub.de. You can fill in your name and register for our newsletter, and we'll keep you up to date. That's basically it from our side. Now we're going to start with the real deal, the presentations. Just two little things. We're going to have a Q&A, as you already know from the agenda. And we're going to use our cool tool Slido again. You can just type in the website name. It's sli.do, Slido, and fill in the name Genesis to join our group. You will then be forwarded to something which looks like this. And you can just type in your questions, and after the presentation, we will come back to you. Next to that, we will also pass around the microphone if you're not interested in typing in some stuff and you're more like the talk guy. So feel free to do it however you like. So now we're going to start with Rchain, I guess. Tim is not here yet. So we're going to start with foam. We got a chain. We're going to start with Rchain. Or Tim is here.
Woo, woo.
You can 3 minutes. Okay. Then we start in 3 minutes. I think we just have to put in the new stuff. You can grab some drinks, visit the toilet if you like, and we'll start in a second.
Good evening. So this was really last minute, I would say. Thanks for your understanding. I'm currently connecting to the Wi-Fi. And once this is there, I can load my presentation. And we can directly dive in. So maybe as a first heads up, if you have seen the invitation, you're probably remembering that there was somebody else announced. And I was asked from Kevin from Reflective Ventures to jump in last minute. That's the reason why I am here this evening. But I will present Ventures with a short introduction so that you have an understanding what Reflective Ventures actually does from Rchain. Wonderful. So we can start. Actually, those guys, right? So Minal and and Steve. They are both members of Reflective. Reflective Ventures itself is part of the Rchain ecosystem, which means this is what they do. Reflective Venture is a venture fund which has a dedication to move the blockchain ecosystem forward, to accelerate blockchain adoption, and to ensure that the blockchain technology actually succeeds. To be more specific, what they do is they are all experienced venture capitalists or from private equity like investments. They have a long year experience in that field, and now they invest in crypto projects. In crypto projects, obviously, which are helpful to adapt the Rchain ecosystem itself. They seek deals internationally, so if you belong to a D-app, which might be interested in adapting to other platform because you're built, for example, at the moment at Ethereum, that might be a good opportunity to request some funds for you. If you have interest after that presentation, just let me know. I can forward that to the right people. If you have general interest, I will also give you the opportunity to just drop an email there. Reflective has signed since February, since they started in February this year, 12 partnerships with different teams around the world, and I have a pipeline of 80 companies right now. They hosted 8 events, mainly in the US, but they're starting now to reach out to other regions as well. That's the reason why I'm here today. For the process itself, so if you ask yourself, okay, how do I get funding from Rchain Ventures? I want to walk you slightly through it from a high-level perspective. It doesn't really matter in which phase you are. So you could be very early, or you could be already in the ICO, pre-ICO stage. That's not a big deal. It could be also just a private sale or a university alliance. There are really all varieties possible. So if you have an interest, you can be at any stage and you can jump in there. Things which are turned away are especially companies which only provide consultancy work or don't have a value proposition. The screening process is the second stage, so Rchain Ventures will check with you to see if there is a real value added to the ecosystem, pretty much. So this means they will check with the risks and with the opportunities, especially when you have different competitors and so on, how are you positioned. It's very important for them that you have a good argumentation why you add the value here. The screening is the first phase, and then it goes over in a more deep analysis, especially when you request a lot of funds. Right? So this is part of the due diligence, obviously. They will check your business model. They will check if you have a good token economics. They check the teams, the technology behind it, all those things. It's really important for them just to minimize, obviously, the risks and to ensure that this is a good investment. That's part of the diligence stage then of the project. When it comes down to investing and to sizing the investment, it is clear that it really depends on the return and the impact the technology can have. So if it's settled here, so 2.5x to 3.5x in return, the threshold, obviously, to give funds is lower for lower funds, but there will also no major investments be given. So this means lower funds are also distributed to those projects, obviously, because of the lower chance of having a high return there. The larger ones are those with a lot of impact, which can have a 10x, for example, really scalable, and they have the chance of getting also more funding. But this is directly connected to how they will be part of that project. Obviously, if you get more funds, you need to provide more equity and more voting rights for Reflective to steer the project in the right direction if possible, and to ensure the risks of the side from the venture funds are covered accordingly to the investment. So this is the whole team. So currently there are 8+ people, mainly in the US. Unfortunately, like I said, I cannot be here. I'm personally very strong entangled with Kevin. That's my point of contact for the most important things there. Because I will go through it over it a little bit later as well. We also speak with ventures for potential investments. When I say we, I will present you what I mean with that in a second. So if you have any projects, like I said, come to me, speak about it in a break. We will check if it's a hot project, if it's really interesting, if it has a lot of spice to it, then I will move it forward to a direct contact. If not, I will just forward you to the general address of Reflective and I will look into it. So the Rchain funds portfolio in general, it's not dedicated to one vertical. So you can be music industry, it can be like adult industry, it can be art industry, it can be anything. Really anything. It's not like dedicated to one vertical, but it needs to live on the Rchain ecosystem later on. So if it's at the given moment, an Ethereum project is very good because then you have already experience, especially if you have a POC, it's very good. It's faster to move it over then. And the deal size itself, it's not really limited there. To just give some numbers, they invested in the beginning stage 100 million rocks, which is 35 million US dollars. At this given point, they invested in total-ish like 65 million. All right, that's from the reflective part. That was the reason why I jumped in to speak with you about that part. And now I want to give you a lot of insights, as much as possible, about Rchain as a platform itself and as a technology. I need to check some things before I can do that, and that's the timing. Because I don't want to go over time, so I need to have a short feedback how much time I have for the rest of the presentation. Okay, so 30,000. Okay, I will hurry up then. So my name is Tim Bansemer. I have a background in IT security and network engineering. So I started as a network engineer and then joined later a security firm called Checkpoint. Later on, I was hired by Kaspersky. I think many know Kaspersky somehow. I'm the founder of Implokio. That's the funny bird here in the corner. We do professional services and community outreach. Since June this year, I'm also Rchain representative in Europe as a Rchain ambassador. Yeah, these are contact details, but obviously you only need my name for this. So what we do and how it all started was actually with the Blockchain for Society meetups I was doing in different cities in Leipzig, Berlin, Hamburg, and Amsterdam. And in Amsterdam, in Hamburg, I met another co-op member of the Rchain Corporation. And he just asked me, Tim, you're doing interesting meetups about like society and responsibility and those things. Maybe you're interested in joining our governance conference in Seattle. So the Rchain Co-op Governance Conference. And this was 1 week after that meetup there. And I was able to schedule it in and was flying over to Seattle and learned a lot about the co-op model itself. It's very open, so this means every one of you can register to the co-op model and you can just participate there. Every member has the opportunity to vote in that model. Today, we are organizing Rchain meetups as well. We did our last one in Amsterdam as in Blockio, and we are organizing the first conference on distributed governance in Athens, also as in Blockio. So these are the both parts in Blockio events, where it's all about the community outreach, and the Blockio Labs. So we develop blockchain solutions, especially for the Rchain ecosystem. That's the reason why I'm here. I'm a co-op member. I'm a supporter of the Rchain ecosystem because I think it's a value-add solution. And I think it's the blockchain which has the scalability we need to create actually mission-critical infrastructure for a digital society. So why Rchain? We live in a very fast-changing world. And this is true for the climate change we see, like weathers are getting more and more extreme, but this is true also for the instability we see on a global scale. So this means we have massive displacements through war, we have displacement through also climate change, we have increasing more powerful weapons. So the nuclear weapons were developed like some years ago, but we are developed technology further, and the impact technology has on society becomes increasingly like stronger. So I'm speaking about AI, I speak about rocket technology is being more distributed to like countries which not had them before, for example, North Korea. But I'm also speaking about how cheap it becomes to develop bioweapons with a biolab because of gene sequencing is getting much, much cheaper. You can set up a lab and start sequencing with 10,000 euros today. This was in the millions like 15 years ago. So this is all a development in a direction that we as humans become more powerful with the technology we have in a world which becomes increasingly less stable. And why I'm pointing this out, because I believe that blockchain technology might be a way to give us the underlying infrastructure for global coordination. What does blockchain do? This is, I think, not a new topic for you, but let me ask you, who knows about Ethereum? Just quick show of hands. Most people, that's good. So I will not go too deep into it, but Ethereum is like a global compute infrastructure, and Rchain is a similar thing, which is also a global compute infrastructure for smart contracts. Blockchain eliminates the need for trusting a third parties for processes which we can automate and put on a blockchain through smart contracts and distributed applications, which are, generally speaking, put in the field of Web3, like 3.0. So if we look at Bitcoin and the history of Bitcoin, Satoshi Nakamoto, 2008, 2009, it went live with some implicit, say, critics on the banking system itself, with cancel on brink of second bailout for banks, which pretty much, I think, was a direct hint to the financial crisis in 2007, 2008. And he was proposing with that a different payment system, a different global payment system, which was unstoppable without a third party. And indeed, it runs until today. But you know maybe that Bitcoin has some problems. First of all, it's not a global compute system. And second of all, it's relatively slow. That's the reason why in 2014, Vitalik Buterin started Ethereum as a platform which was much more capable of doing computation, except like not only doing some scripting on top of Bitcoin. With this, I think we had the first killer application, the ICO, being able to print your own money with a ERC20 token, which was a huge step forward to, say, disrupt the power balance we see in the world. Because the first time in human history, we had the situation that seed funding was actually more distributed around the world, was not only focused in hot spots like Silicon Valley. And at that given point in time, we have like similar investments and seed investments in the blockchain space between Europe and the US. So that's awesome. But also other areas like Africa. In this field, in Ethereum, we encountered a second problem. The second problem was with getting more capabilities, we introduced more attack vectors. Because a smart contract can be written very easily, it can be deployed very easily, but it's not very secure in general, because everyone can attack it. It's a public blockchain. And if you have a flaw in your smart contract, you might lose all the funds which are connected to that smart contract. Somebody else might destroy the smart contract. Or the smart contract might just behave differently than you expected it to behave because of the complexity given. So we see that this infrastructure has, at the moment, flaws in regards of security, because we cannot say anything before the execution how this smart contract behaves. And with this question, would you put your life on a smart contract if you run it in Ethereum? Right? So, well, we as a society depend on a digital infrastructure we can trust, because we get more and more devices out, and the standard internet has seen like massive devastating attacks with Mirai botnets which overtake like IoT devices and directed as attacking vectors against other centralized services. Even Facebook, Amazon, and Twitter were down for a while in the US because of Mirai. So what I'm saying here is we need a critical infrastructure which can provide us the security to say, yes, I'm willing to put my life on this smart contract and depend on it. Because we as a society get increasingly more dependent on a secure infrastructure with all the digitalization around us. The third problem we have seen with the given infrastructure and blockchains is scalability. So who remembers those sweeties here? Some? Yeah, CryptoKitties. It was one of the first gamified D-apps which had a high. At the time where CryptoKitties went viral, it pretty much blocked the whole Ethereum network. So that was a problem. And I want to give you some more comparison to make it more graspable. If we do a general election on Ethereum today, it would be 50 million transactions because not everyone is going to vote, right? You have children, you have old people which don't care, and some other people which don't care as well. 50 million transactions, how long does it take for the Ethereum mainnet to process that today? Any hints, directions? Less than 10 days? Anyone? More than 10 days? Or some more, you're right, it's more than 10 days. Actually, if we take 1 million transactions, it would take 50 days, right? Nothing else would happen. It's a little bit more than 1 million transactions on Ethereum mainnet, if I have it right in mind. So it will take way too long, because it's only one country doing general elections, right? So that's not the purpose for it. It's not ready for mass adoption yet. So scalability, third big problem. That's the reason why Rchain was developed. That's the reason why it came to existence, because Greg Meredith actually recognized those problems. Rchain is an infrastructure which tries to approach those problems of scalability and security, as well as having not so much high costs. So actually, I forgot something with Bitcoin, which is, what is the main critics on Bitcoin? Pretty expensive. Why is it expensive? Yeah, I would say energy is like the main concern we hear a lot of time, right? Next to like time and all that stuff. It's, I think, consuming more than Austria right now. By the end of 2020, some people expected to consume similar energy like the US, which is massive. So this thing is eating us. It's crazy. So also at that point is important. We need to have a future-proven solution which does not need as much as energy as Bitcoin for proof of work. And it's possible. We can do that differently. So it's secure, sustainable, scalable. This is what we want to have. How do we get this? So the standard design should promise something like 40K of transactions, up to 100,000 transactions per second. It's way more than we see at the current moment in the Ethereum network, or in the Bitcoin network, or in any other like Bitcoin, like blockchain network. We have tools which obviously need to be developed. The whole platform is developed fully open source. This means you can crack the code and you can develop it for yourself. You can understand it. You don't need to trust any shady company here. You can trust it because it's proven on math. So it's actually formally verified, which means that the building blocks of Rchain originate like in a model where you can prove anything that it's formally correct. So every building component which is built on top of it, like higher order component, is built off like small components which are provenly correct. So this means that you have the ability to really prove the different elements of the architecture to be correct. So the approach is formal and correct by construction. So the formal is, and I need to pardon myself here, I'm not a coder. And I don't have a math background, so I'm coming from an infrastructure security perspective to Rchain. So it's also for me the first time to present it in that way. Bear with me. So formal is like the mathematical proof in the code. And correct by construction means that you can know before how this code will behave. So this means that every edge case of the code you execute will be known before you execute the code, which means that it behaves as intended, which is very powerful. What are the different aspects of the architecture I like to tackle in this talk? This is the row VM environment. So like the Ethereum virtual machine, there's a row VM, which can execute rolling smart contracts. So you can run smart contracts on it. You have the namespaces, which gives us the opportunity to run smart contracts in different environments. So you might need a smart contract which runs really slow, with no additional demands, with no additional constraints. That's fine. You can run it in a namespace which has low resources. But you can run it also in a namespace which belongs to Rchain, some new terms, I will go into it, which has high compute performance. So this network or Rchain infrastructure can allow to have different so-called rechains with different requirements on the computational resources and constraints, how fast it needs to run there. We have the Casper proof of stake consensus protocol. I think proof of stake is something different than proof of work. Proof of work is what we see in Bitcoin. Proof of stake is what Ethereum is currently moving to and what Rchain offers by default, which means that you do not solve a mathematical puzzle, but you take some money, lock it into a wallet, so a digital purse, and stake that as a risk that you lose all this money if you cheat. And then you can participate in signing transactions. And then it will depend on how much you stake if you are getting a block reward or not. So to wrap it up, you put a lot of money, you put it into a validator node, and then you have a percentage of the staked money of a chance to get a block reward. So a little bit more aspects I like to cover is what we see, say what we need for scalability and what are attributes of rolling itself. It's a completeness, so this means that any computational function can be expressed in rolling itself. You have the compositionality, which means that that the small atomic elements are used to construct higher order elements. So like cells form an organ. It's a little bit here. You have the small, the smallest unit, and I will go into it, which forms the higher order, models. You have concurrency, which means that things can run in parallel, independently from each other, if they're not related to each other. So we all can have a talk together, but we couldn't have the same, another speaker on the other side of the room speaking in the other direction because we share the same space. And with that, we would get noise collision, right? We couldn't really understand what the other one is saying. So what I'm saying here is, as long as transactions are independent from each other, they can run concurrently. I give another example. You go to a market in Shanghai and you buy a coffee, and you go to a Starbucks in Seattle and buy a coffee. In Ethereum, both of these transactions would be booked in a sequential way. This means in a list to the whole network, and they would be processed from the whole network. But in Rchain, if they're not related to each other, they can happen in parallel, or concurrently, to be precise. And we have metaprogramming reflection. This is some crazy math stuff for me personally at the moment. I think in a half a year it will not be anymore. But this means that you can be aware of the own code you are. So give me a second. You can be you can perceive yourself. Code can perceive, so a program can perceive itself. Okay, so you can actually know what code is run. There's a problem which is pretty much saying that you can have a program, but it will never know that this program is a program in the program. Okay, and the self-reflection means that there is a reflection opportunity. Let's go further here. So parallelism, this is what you have when you have different lanes and cars driving on those different lanes, and they cannot switch lanes. This is parallel. Concurrent means that you can switch lanes, but you need to check if a car is next to you. If there is a car, you should not switch lanes because then you have a collision, but if it's free, you can move over. Okay, so this means that's a concurrency we speak about. And it's about resource management, obviously. Because you need to know if transactions are related to each other or not to be able to make that decision if they can be executed concurrently or not. So why do we need a new calculus for that kind of language we build with Rchain, so the row calculus, to form the Rchain? So there is a problem with distributed computation, especially if you think about memory and storing data. Like I said before, when you want to do a transaction on Ethereum network, you need to wait for all the transactions which are listed internationally. But we want to have a way that we don't need that, and that's possible with the actor model. The actor model is way closer to how we act. Like every one of you can act independently. And if you want to speak with each other, you pass messages. This is the actor model. So every actor itself is pretty much the atomic unit which can send messages or receive messages, but has its own state. So we don't have a shared memory, but an isolated memory between each actor. Like every one of you has their own mind to store data. And every one of you can have their own thoughts, and you don't share them with others, so we act independently. That's the actor model we see in Rchain. And we have a mobile processes based, which means that you pass transactions between those different actors, and you can spawn new actors as well, so child actors, so to say. This gives us the opportunity to, say, spawn independently from each other as much actors as we want. And you can see them in the computational science field as a process. This is just spawning different processes. This is what every actor can do in Rchain. So this is do nothing, just sticking around there. When we receive a pattern on a channel, so I receive a message on my ear because you say something, I do something. So you say walk over there, and I walk over there. Okay, that's that second part. Send P on channel X. I can define a channel. For example, I have your phone number and I send you SMS. That's the defined channel. And I can have the option to send you a message if I have your name and your phone number. So, or your phone number is the name. You can run two things in parallel. So if you have this sign, you can run things concurrently, so to say. This means doing multitasking. And you can dereference a channel that's a little bit difficult to understand in the beginning. You need to differentiate between a process and a channel. A channel is where you can send a message through. A process is something you can interact with and can send a message to. And this is just a way of quoting processes with that ad. So let's skip that one and go directly here. How much time do I have still left? Okay. So this is a very, very simple example. And like I said, I'm not a coder, so bear with me. I will try to walk us through this example. Oh, that was too fast. Here we go. So we create a new private channel. This is the Hello World channel. And then we can send a message to it. But let's walk it through from the third line to the first one, because it's actually easier. So we have a return hello world. So this return hello world is sent to the channel return on a smart contract hello world. And this means it sends, so to say, itself a message, okay? And then we have, in the second part, in parallel running, my channel which is just an opening of a channel, to Hello World with the content of my channel. So this means we create a channel which then converts into a process with that star to send itself to the smart contract Hello World. This itself wouldn't do anything, actually, because it would not start from its own, and it would just create its own instance of itself. So without any STD out or something like this, you cannot even see something. That's the reason why we created at the moment an online instance where you can just check this out. This is Rchain.cloud, where we run a real-time compiler, different like VMs in the background nodes, where you can execute rolling. And then there you see that we implemented with the latest implementation stage STD out for debugging. Okay, so if you want to play around with code, if you do like coding, there's a good good documentation about it, and also like a detailed explanation about the Hello World example. And you can run it directly without setting up any additional infrastructure on your laptop in the Rchain cloud environment. So let's go a little bit into the history. Craig Meredith actually developed or started to develop the row calculus in the mid-2000s as a reflective higher order process calculi. And he actually followed the footsteps of Robin Milner there. And he was at that time also working for Microsoft. He tried to push that project forward. A little bit later, Synergy arrived out of that. This was pretty much the approach to build a social network on top of a blockchain. Okay. So this is really important for him personally. He says the most important applications we need to build on top of a blockchain are messaging infrastructure to do mass coordination. So for mass coordination, we obviously need, say, the critical backbone we can trust to exchange messages in a way that they are trustworthy. But also think about a social network. If we want to build a distributed social network, we need millions of transactions per day, or like even maybe per second. And we need to have a way of not only putting it on a computing infrastructure, but also taking this to find a way to distribute the decision-making processes. So who is setting up the rules, which content is allowed and which content is not allowed? And now comes a little bit my passion from the governance debate we have in the blockchain space right now. Who is allowed to define those rules? And how do we define those rules? Because in our society, this comes from usually something like a constitution. And a constitution is the reflection of a consensus on which principles and value we share. So if we want to find rules for a distributed social network and govern it distributed, we need to find a way to coordinate what principles we share in a community. And then we come into the challenge, do we want to have one social network for everybody where we have the same rule sets, or do we have like a social network which is more like a federation? Different zones with different values, with different rules, which have trust levels to each other to pass messages. Just to think about that, that's the direction I think some other people are thinking as well. But to get something like a distributed social network, which is politically distributed and which is just open, shared communication infrastructure of humankind, we need to find a way to do the political distribution power process, so to distribute the political power there. Let's go back into the tech, because I just jumped into a whole different debate. This is around the consensus algorithm, CBC Casper, correct by construction Casper. Vlad Zamfir is actually leading the dev team here. He is also known from the Ethereum community. And that's the new consensus algorithm which will find itself in Ethereum and in Rchain. It's actually a consensus family, like proof of work is somehow. You can have different rules or different implementations of proof of work. We know today that there are thousands of possible consensus algorithms. So the consensus algorithm itself looks a little bit funny. So it's not like a classical structure that you have one block after one block after one block, but you find a way to find consensus a little bit differently. What we see here is a DAG based on 3 validator nodes. So you have 3 nodes finding consensus together. And what you see is that they do these funny spikes here on the side, which then die. Okay, these are side chains which then later die in the process of finding the consensus. The beauty of this is it's much faster. So the validator nodes itself, they will actually bet on how the future of the blockchain will look like. And if they bet right, they have the chance to get to receive the block reward and to actually write or say distribute that consensus as well. So if you all think in this room that something is very likely to happen as a future event, this would be the way how the validators form the new version of the blockchain, which means that they can include can include hundreds or thousands of transactions, as long as they are very likely to happen. So they build all up the mempools with all the future transactions, and then they guess on how the future of these transactions will look like. And you will not include something which is very unlikely or strange. For example, there will be no frozen cow next to me in the next 10 seconds, right? You wouldn't give a bet on that, right? So that's the beauty on it. It's they stay sane in a way. They bet on the future because it's the only way how they get rewards. That's the consensus. Let's move over to the way how we structure the nodes. So a node itself, for example, a validator node, can be put in a region. So like we have continents on the planet, you can have in Rchain different regions. A region is defined by a specific rule set. So for example, how fast goes your processor, how much transactions can you process? Over 1,000 transactions, then you come in region 1. Less than 1,000 transactions, then you go to region 2. And you can have unlimited amount of regions. And the namespace, so this means where you live, like we live now, or we are currently in Munich, or you can be in Berlin, but then you need to travel there, if there is a path there. This is how regions act as well. So you have a different, like a specific policy rule set, you can compare it with, you have policies in every country. This is one region. As long as you follow the policy, you can stay there. If not, you go to jail or you're thrown out. This gives us the opportunity to have different constraints and form different instances of the Rchain network. And if you think a region does not have the right constraints, you can just form a new one. The node itself, like the validator node, can then bound to a region. So this means you can, as a validator, can look, okay, which regions are there? What are the constraints? Okay, I want to join there. And then you try to join there. You need to be accepted as a validator. And also if you unbound, so the acceptance is not a big deal as long as you speak the same protocol, you run in. But if you unbound, then there is a constraints, which says if people are still in that region doing stuff and transactions need to be handled, you need to stay if you're one of the last validators. You can only leave if new validators are coming in. And then you have the slashing. So for all those validators which don't behave, they get slashed, to keep it simple. The distribution of rewards is for those which predict the future the right way, and then they have the chance given to stake how much block rewards they get. So the regions itself, say it's like the nation states or whatever, this is really only comparison. It's lacking a little bit of correctness here. But in those different regions, you have namespaces. So like we have names for cities, you can have names for different, say, processes. Or for, I always think about agent, but it's not agent. It was the thing I mentioned before, the actor. You know, the actor and the agent, I always mix them up. So the actors are actually, they can be named by the name system, and this gives you the opportunity to speak to a specific person in this room if you know his name, but in Rchain it means that you can speak with a specific actor. So you can send a message to a specific smart contract, for example. Each user or each smart contract can be represented by a name, which is living in a specific region. If we want to do all high-performance computing, we need to go to a high-performance compute, say, region, and then we can do high-performance computation because the region allows us to do so. So you can select where you want to have your smart contract or in which environment you want to operate. If two regions want to speak with each other, they need to share a set of validators. So this means that validators from both regions need to join this third region. And then they need to comply with both rule sets of both regions, and then they can pass messages between smart contracts, for example, from both regions, which is awesome, which means something like Polkadot is doing, right? Like communication between different blockchains, so to say. I will skip that one for the sake of the time and just show you this one. So you have these two regions I was speaking about, and if they want to speak with each other, they can do that only with a third region which is created from validators which are sharing both regions. And with it, they create a third region actually, because they are now complying with the rules of both regions they want to bridge. And then you can even have the same, say, a smart contract, which is under the name World Earth Munich, just a stupid name here, from region 1, with the same from World Earth Munich in region 2. And the reason is because this is coming from region 1 and this is coming from region 2, and you could imagine to put this just in front of here, and then you could differentiate them, right? So because they know where it comes from, region 3 is knowing to which regions it's communicating, so it can even pass messages between smart contracts which have not the same name because they live in different regions. So this is the summary from the technical part. Before I do a small announcement. Rchain is the approach to build a scalable, future-proven, secure blockchain which can actually enable ongoing development, which is like in Ethereum, like forking like every 6 months or something like this in a planned way. You can just spawn a new region, define new rules, apply new code, and as long as it has compatibility to other regions, you can like pass messages or port smart contracts. We have all needs covered for private, public, or consortium chain, because with the namespaces you can create all those. You can create private chains, but you can create also public chains. If you want to create a private chain, you just spawn your own region and define as a constraint that you need to have a specific certificate to be a validator node, and that's it. It's the same way how you can spawn a consortium chain. As long as they actually operate with a subset of the constraints of the mainnet, they will be able to communicate with the mainnet. So as long as you comply to the EU rules, if you are living in any country in the EU, you can properly travel to another country in the EU. Okay? Even if you're from like Poland or something like that, because there's a higher restriction. As long as you are a subset of rules in your region from the region you want to speak to, you're fine. You can do anonymous transactions, you can even create like system smart contracts to do zero knowledge proofs, and you can do much, much more. So it enables a lot of things we couldn't do with the classical computational model we used, or which was used in Ethereum. Outside of the protocol and of the technical talk, Rchain, like I said, is a co-op. So if you want to become a European co-op, the European membership will be available soon. It's actually in this week that European co-op will be formed. And if you want to join there, you can just write down your email address, or I will just send you out an email address to send it to just after the talk. And we can do a pre-registration. I can pass then later the contacts to reach out to you again. Officially, it will be launched in September. It's pretty easy. It's just $20, and then you can participate. But actually, we are looking for people which really want to contribute as well. In the one way or other, you don't need to be a technician to participate and to contribute, because there are a lot of other topics related to behavioral science, to distributed governance, to like other stuff, to outreach, to event organization, a lot of stuff you can do without being a technician. And we are currently forming the board in the European co-op, which will be then later opened to the co-op members to form that newly. All the details are pretty much on rchain.coop or .member.rchain.coop, so you find all the details there. It's pretty straightforward. So I will bore you with more links here. If you are a developer and you want to go into a deep dive, be aware of the meetups we announce and just join there, and then come to the Rchain in Berlin from the 3rd to the 6th of December, which will be a very technical deep dive onboarding for their developers. If you think about it like collective intelligence sometimes, this is just a different perspective to see it. I found that on Wikipedia and said to myself after speaking about distributed governance and blockchains, holy cow, this is crazy. Because what we are building at the moment is going into the direction of collective intelligence. And let me pinpoint why. Prediction of future events in policies and technologies. Does anyone know a blockchain startup which does prediction markets? Which one? Gnosis, yes. But we have also, I think, Augur, I'm not sure. So we have more prediction markets, right? And we have market judgments with it, so that's a cognition. We see a peer-to-peer businesses, network of trust, open source development. What would you say is this? Blockchain infrastructure. And then we have coordination, ad hoc communities, coordinating collective action. This is all around distributed governance. So this is where my guess is where we are heading to. But let's see if this is right. Peace is linked with global governance. This is the Paris Peace Forum, very governmental-like. But they say global governance. There's more to global governance, for example, regulation of international companies, but also regulation of blockchain infrastructure. Because as a node operator, you have a really different jurisdictional zone. And as long as there is no global law, you can just go to the sea or to Singapore or to wherever you want to go to run your nodes. So if we want to have coordination on a global scale, we need to have some form of global governance. How this form looks like, I have my personal view on it. I hope it's not one state ruling all the others. That's the reason why I'm also the initiator of the first conference on distributed governance in Athens. So we are bringing together different fields, not only the blockchain field, but we are asked also for policymakers which think that there is a need for global coordination, but also practitioners, SEMCO, SEPO, those which do distribution of decision-making since a while in their culture of the company, and those blockchain projects like the DEX, distributed exchanges, or the DApps. If you want to form a DApp, decentralized autonomous organization, a DAO for your DApp, you need to find a way to distribute the political decision-making. If not, it will be a team which is centralized. And then it's really, again, a single point of failure. So that's it. Thanks a lot for your attention.
So, Tim, thanks a lot for introducing Rchain, and props to you for doing the technical thing. I know Rchain, and it's not easy to explain. It's actually pretty hard, and I think it's one of the hardest tech stacks to really get on a fundamental level. So, props to you. I got some questions in our app. Maybe we start with those, and whenever you feel that you might have a question, just grab the mic from Julius, and yeah. So there's actually a lot of stuff. Some questions relate to the cooperative model. So you actually explained that. So basically that everybody's able to join. It's an open process. So I think we can skip those. Another one would be, how would you compare Rchain's computational energy consumption with Ethereum or Bitcoin? So that's probably...
So related to the energy consumption, we need to make a distinction between proof of work, which is currently used in Ethereum, and proof of stake, which will probably be used in the future. With proof of work, it's pretty much guessing a math puzzle if you want to get a reward. And that's pretty hard, and it takes a lot of computational power. And if you don't use that principle of guessing a number, it gets much easier to find the right solution. So I would say, and this is a guess, right? But I think by a factor of the current energy consumption you have like having it like Austria is just crazy in Bitcoin. If you run computers for Rchain, they would need the energy like what the computer needs, and then it depends on which many validators participate. To make it really simple, it will use way, way, way less energy. So probably of a fraction of 100 times less or something like that. But don't name me down on the numbers. It's just a totally different principle to achieve a solution. And there is no need to burn energy, which will then not be used anymore. Because every node which tries to find consensus in Bitcoin and failed pretty much spent time burning energy. This is not going to happen in proof of stake.
So another one would be, do you think that there is a place for off-chain governance in the future? Is on-chain governance the way to go? Pretty interesting question. I like that a lot.
I think to just clarify what is off-chain governance and what is on-chain governance. So off-chain governance is everything what we usually understand as finding consensus in a group. So if we speak with each other, that's off-chain. If we coordinate on a forum, it's off-chain. If we have a telco, it's off-chain. On-chain means that rules for finding consensus are implemented in the code. And if you do that, for example, for forks or how to change the code run on a blockchain, then it means that it eliminates the debate from the different stakeholders. So there is no human-to-human debate anymore between the code, the node operators and the developer or the other stakeholders. And that's problematic. So on-chain governance, if it eliminates the human way to find consensus, would allow, for example, to just push code to nodes and you do not reflect on it anymore and there is no debate and you just implement whatever code comes downstream, which was on-chain agreed on. So I think it's very important to do off-chain governance. I believe that we should find new principles for doing, say, coordinated off-chain governance and to combine it in some certain cases with on-chain automated decision. But if we do automated decision with on-chain governance, we need to be very aware because algorithms can be biased, they can be racistic, they can be very unhuman and not with moral implications, or they don't have moral code, right? Or they have, if we implemented it. So it's very dangerous. We need to be very specific with this.
Thanks. Yeah, it's a scary thought, right? That like there's only the technical consensus and in no way any social consensus involved anymore. So if we skip that part, it's actually pretty scary. Yeah. Especially if you do combine it with AI. Yes. All right. Another one. So any questions from the audience? Actually, anyone? Or just busy typing questions on the app? You are. So another one would be, are there any use cases planned? I think you have had one slide with Resonate, which is kind of a streaming service. So, but I saw a lot of other services on the slide. So maybe talk about those.
Actually, any industry which has like some kind of platform which interacts between users and producers somehow will in the long term see a blockchain version. So use cases are in every field of life and there are so many that you cannot count them. In blockchain consultancy, it means that you cannot give a general answer if something is suited. You need really to check what they want to achieve with it. But to give some handy answers to that as well, digital identities. So to have a digital identity hook, so you're able to like control your digital data is something we will see in the future, and this is done with Uport, for example, in Ethereum. Digital voting, Votem is doing it on Ethereum, so we will see a way to minimize costs for general elections to nearly zero, because we now have a technology how we can do trustworthy votings. And this is just like the peak of the iceberg. International transactions obviously is a no-brainer, so finance industry, insurance industry, automated insurances in the combination with AI, especially to model risks, is done by EtherRisk on Ethereum, for example. So all use cases you see in applications on other blockchains are suitable for Rchain blockchain.
Where do you see Rchain in the next years? Next step in the short term, like 1 to 2 years?
I haven't really spoken about the roadmap, so I can only say it's moving very fast at the moment. We will see a testnet deployment in September, so this is also very important to be aware in which state we are right now. It is very high valued, so if you look it up, it's like over, or I don't know if it's currently, but it was having a valuation of over 500 million. And this means that there is a lot of focus on it, but you will see like the first testnet implementations with the Rchain 3. But at the moment you can run your own nodes, and with the update for the one, I think you can start that they speak with each other. So you can also run your own code on it already. This is the state we're currently in. For 1 year, the public launch should be in December. This is very optimistic, I would say. But maybe we stay with that. We will see, right? As long as I see it right now, timeline was kept, so we can be optimistic. So we will see the emergence of the Rchain mainnet definitely in the next 12 months.
The biggest competitor of Rchain, who is it?
Good question. I think if to answer such a question, you need to know the competitor, right? So I will not rant about other blockchains. But I think to give an answer, you need to look at the computational model. If it's not a new model for distributed systems, if it's just the same computational model we use all along, then it's probably not a competitor for us. So I think it's really about other blockchains which approach the distributed consensus problem with, say, with atomic units like ants, which can like coordinate with each other without central units, which uses a computational model which does not has a shared memory or the need to process things sequentially. So really blockchains which are not really blockchains anymore, but distributed consensus protocols. So which, you know, like the Tangle approach is interesting to watch, but I don't see like a good implementation of it yet. I think those things are the thing to watch out. Hashgraph, for example, is an interesting approach, but then it's the question how it's implemented and how it's executed. So yeah, I think that's a direction to look at. But the classical blockchains will not reach the scalability, I'm afraid, to be a competitor.
That's all from me, I think. So if there are no more questions from the audience, I think we can move on to foam, right? So yeah, let's do that. Arthur will introduce foam, and I think that foam is like one of maybe the most crystal clear hands-on use case I've seen and I'm aware of in the blockchain space. So I'm really enjoying the product and vision. So yeah. Please welcome with me Arthur from Foam. And thanks, Tim. Thank you.
Okay. Hi, everyone. Yes, so my name is Arthur Rchain. I am the creative market director of Foam. We're a New York-based company. I sit in Berlin. And yeah, I'm going to speak about this company and what we're trying to do. And in relation to the previous talk, maybe the easiest way to understand what we do is if you have these kind of consensus models and a functioning root chain with scalability, we develop geospatial standards, protocols, and proof of location that enables real-world use cases to come out of this. Specifically, we talk about and we build ways to talk about spatially specific smart contracts, how to visualize and interact with these smart contracts from a consumer perspective, and also most importantly, how to verify that smart contracts are where they claim they are. In a decentralized way. And we do this through three elements: the cryptospatial coordinate standard, the spatial index and visualizer, and our flagship element, proof of location. The cryptospatial coordinate is basically a standard that can be used by anyone within the ecosystem to refer to smart contracts that are in a specific place. The spatial index and visualizer is a way to visualize and interact with these spatially specific smart contracts. So if you have, let's say I'm building a decentralized Airbnb, I can do a spatially specific smart contract, and then users can interact with it through the spatial index and visualizer. And thirdly, and as I said, most importantly, we are developing two solutions to proof of location, which is basically, if you have, how do you know that something is at a certain location, and how can you source that information in a decentralized way? And we solve that first through a static proof of location protocol that is basically community consensus. So you have a community that agrees on that, let's say, McDonald's is at Hauptbahnhof here in München. I don't know if it is, but it probably, you know, it's an example. And dynamic proof of location would be, is a car in front of McDonald's at Hauptbahnhof right now, which is a bit more tricky, and I'll get into how we're solving that. But I'm going to go through these elements one by one. If there are any questions during my talk, feel free to just raise your hand. We're going to have questions at the end, but I like if there's anything that's unclear, just ask me. So these three elements can be used independently, but they really shine when they come together. And the first one is this cryptospatial coordinate, which is basically a solution to this problem, which is that a lot of people are deploying and building stuff right now, but they're not building it with interoperable standards. So what we're doing is we're proposing a standard for basically referencing space when you're doing when you build smart contracts, and we do that by combining the open standard, the geohash, with an Ethereum address, and then we have what is called a cryptospatial coordinate, and now we have a registry of spatially specific smart contracts. This is our office in New York. We only have one part of that. That's not our whole. And that's the CSC code for that address. So now you can, and now you have this registry that is shared between all projects that develop smart contracts and for different purposes, but there's a shared registry that can be used interoperably between the different projects. And so now you have this registry. So our second thing is the spatial index and visualizer, which is, okay, you have all these smart contracts that are spatially specific. How do you visualize them? And currently, there are no general purpose web applications that enable developers to build anything. A lot of stuff has to be built from scratch. So what we're doing is we're giving this open source tool to provide to an ecosystem of developers that can now build spatial applications. So with the example of the Airbnb, it will be the interface that you use to interact with smart contracts that represent, let's say, an apartment. I'm not going to go too much into this, but basically this is the stack that we built. It's built on Mapbox, which is in turn built on OpenStreetMap, which is a crowdsourced map of the world that we really believe in. I'll go into that a bit more later. And it can be used by anyone. So it can be reskinned. There's no tokenization attached to any of this. So we're really just developing this and putting it out there to kind of help an ecosystem grow around spatial applications or decentralized applications. And the way it looks today is this. So you can navigate spatial smart contracts. There is already a beta up on beta.foam.space if you're interested. We use MetaMask and Uport for identity. And basically you can navigate and deploy smart contracts there today, but this is just a kind of showcase of the web application. So it could be anything. Your creativity is the limit here. So this leads us to our third and most important element, which is proof of location. And the general question that proof of location tries to answer is, how do you verify location claims in a decentralized way? Like I said, is McDonald's there at Hauptbahnhof, or how do you know that a car is at Hauptbahnhof? And static proof of location answers the question, is McDonald's at Hauptbahnhof? So it is a static location what we call a point of interest, which is a special category of map data, which is really hard to curate. So Google and Foursquare are working very hard on this, but it would be points of interest for the general population on a map that are constantly changing. So not a, let's say not a mountain, but rather, yeah, a store or a pop-up or something like that. And what we're doing is we're using what is called a blockchain primitive, which is the token curated registry, which is a new form to curate lists in a decentralized way, where you basically align the interest, the financial interest of the people within the community around this list with to build as good of a list as possible. And we're doing that especially for these geospatial points of interest. And we're doing that because there are already really good tools to crowdsource this information, but the problem is that as soon as you have financial value attributed to them, and in this case it's just Pokemon, you will already see people manipulating it. So here people realize that since Niantic, which is the company that built Pokemon Go, built their product on OpenStreetMap, which is this amazing crowdsourced map of the world, which I talked about earlier, they could just deploy, let's say, a volcano in their backyard. And then they had to wait a little bit, and then they could see that manifest as a as a Pokemon in their backyard. Let's say a Charizard, which is a fire Pokemon. And this will, you need kind of skin in the game models or curation ways for these crowdsourced maps, basically. And that's what we're doing with the token curated registry, together with this cryptospatial coordinate, which I explained earlier, which are these location-specific smart contracts. And then we have this community-driven map of points of interest. And the way it works is basically, I don't know if everyone can see this. Do I have a, well, anyway. So basically someone adds, in this example, the Eiffel Tower, to a map. There is a child, so they have to make a deposit, which basically means they have skin in the game. They make a small deposit of foam tokens. There's a challenge period where either everyone is happy and it's directly added to the map, or someone challenges by putting in the same amount of tokens. And then there's a challenge period where people vote. So the whole community comes together, they vote on which option they want, either yes or no. And the question is, do you want this to be part of the list? If yes, then it's added to the map, and the deposit of the lost party is distributed among the winners. If no, it's not added to the map, but the same thing happens. So there is a financial incentive for people to interact and help curate this, this list of points of interest. And of course, we're building this with the spatial index that I showcased before. This is what's going to look like. If you're interested in more, there's much more to dig into for this specifically on our blog. But I'm gonna, for the sake of time, I'm gonna talk more about dynamic proof of location, which is kind of the next thing. But this will launch over the next 2-3 months. Yes. 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 If you put the point of interest in, yes, your stake is distributed among the people that challenged you, yes. Okay, so the second proof of location standard is dynamic proof of location, which is basically, yeah, as I said, the car in front of McDonald's, which is an agent or event verifiably at a certain point in time and space. And most of you, yeah, don't know what this is, but this is normally how we do this. This is a GPS, or this is how the GPS system works, or looks. These are 32 satellites that constantly spin around us. Every time you locate yourself today, you pick up your phone, all these satellites say beep, beep, beep constantly, and you locate yourself in relation to those satellites by listening in what the time difference is between that beep between each satellite, and then you know the difference. So you say, okay, that's half a second, that's a little bit more, and then you can position yourself in relation to that through a process called triangulation. This is amazing, right? This is like the peak probably of human engineering as it is. The problem with this is that it's really bad for certain processes, all right? So for certain processes, and it's especially bad for certain processes that are automated and have financial interests involved in them. So For example, you have the problem with GPS is that the GPS, you only listen, but the GPS don't listen to you. So basically, when you get a GPS position, when you position yourself, you can just you can install an app, and that app lies what you heard, and it just says, no, this is took much longer for me to hear that beep. And therefore, you can position yourself where you want in the world with GPS, because the GPS satellites themselves do not keep track of where you are. It's a one-directional communication and not a two-way communication. So in a lot of use cases where you have automated processes, like, for example, an Uber car, they have huge problems with spoofing because drivers, for example, manipulate their own GPS data and then get much higher wages because the processes are based on the GPS input but are automated. And this is, again, also happening in Pokemon Go, where kids figured out that they could download an app and then just move across the maps continuously and just mine all the Pokemons. So, and this is a huge problem among a large number of industries, but it's especially problematic as we move into automated smart contracts, which we're all kind of working towards, where you want to have geospatial input, and that geospatial input isn't verified by anyone, and anyone can lie about it. So it's going to be totally impossible to build real-world applications that are automated on blockchains without bilateral signed location verification. So what we're doing is building dynamic proof of location by using these four by these four parts. We're using synchronized clocks and triangulation, the same way GPS works. We're using low-power wide-area networks with a form of radio standard that I'm going to speak more about later. We're using cryptoeconomics and incentivized proofs to ensure growth, but also ensure that people that act maliciously within the system are slashed, the same way proof of stake works. And we're using different consensus models for local and global consensus to ensure that we can scale this. So basically, our solution, dynamic proof of location, is a number of ground-based radios that the same way GPS locate you or any agent within space. But what is done is it's signed by both parties. So they publish anonymously signed what we call a presence claim, and you have a public key, and you can say you have a collection of presence claim as a user, and at any point if someone asks you, let's say you want to unlock you're a supply chain. Pokemon Go is a good example. You're going to a place, you want to unlock a Pokemon Go, and the Pokemon Go says, well, are you really there? And then you can disclose a presence claim and you unlock the Pokemon Go. And the Pokemon Go app or decentralized application in this sense, it can be fully confident that you have been there. And we do this with a radio standard called low power wide area networks, which are very small. They're about this big. They have, in remote areas, they have 15-kilometer reach. In urban areas, about 5. And they have very long battery life. And they're very small, and they're not that big. But what's also really important is that they're permissionless to deploy. So anyone can today deploy a LoRa chip. And there is already a community of LoRa enthusiasts around the world called the Things Network. And these are radio hobbyists that deploy these without any economic incentive worldwide, and do so to kind of power small communication between IoT devices that they set up, let's say a little button or something. We think, or our proposal is using the same kind of networks for triangulations. We think that the Things Network is already proving that you can build these communities really fast in urban environments. So this is Zurich. This is the world's biggest. I was there yesterday and had an event with the Things Network there, which was really interesting to hear about how they've grown so fast. And this is Munich. And the chips are about this big, and a setup costs about 200 euros. So much cheaper than a mining rig, for example. And it's pretty quick to set up in a city. And I'm going to walk through quickly how you would set up these zone anchors. So basically, zone anchors are set up by installing these chips and deploying them in the city. They synchronize their clocks and then form local zones by staking a number of foam tokens and creating what is called a service level agreement. So basically an agreement that if they don't follow the rules of this network, their stake is going to get slashed. And then basically, when a user or an agent enters the existing zones and drives through or moves through, they can collect presence claim from these in return for microtransactions. So what we have is a trustless system through Byzantine fault-tolerant clock synchronization that is independent because it doesn't rely on a centralized service like GPS. It's open because anyone can use the network and anyone can become a zone anchor. It's accountable because the economic incentives are aligned with honest behavior, and it's also verified through fraud proofs. And it's incentivized because service providers receive block rewards and microtransactions for setting up the zones. And all of this I described until now is basically what we see as a middle layer for making it possible for other people to develop geospatial applications on the blockchain, and which of course has an impact on a variety of different use cases, right? So any kind of, we see any blockchain application that wants to interact with real space and wants to do so in a decentralized way and wants to have basically automated processes that rely on geospatial input needs a protocol like foam. So from mobility to supply chain to location analytics to IoT, geospatial data markets and automated insurance claims. And in our system, the token has three functions. It's used, as I explained earlier, to add and curate geographic points of interest within the point of interest token curated registry. It's used to stake for signaling for zone incentivization. So early in the system, you're going to be able to use these foam tokens, deploy them in an area, and then that's going to manifest as block rewards for the people setting up zones there later. And of course, thirdly, as staking, to contribute as a zone anchor or verifier within the system. We're selling these soon to the general public and anyone that wants to become a zone anchor. And yeah, if you're interested more in that, you can check it out on this URL, foam.space/token. And we have strong partnerships in place to make this happen, including the Trusted IoT Alliance, the Ethereum Enterprise Alliance, Mobi, which is a consortium of mobility partners both in the blockchain space and the classical mobility space. And we already have over 20 local communities that are interested in setting this up. So yeah, that's about it. You can find out more about what we do on these different URLs. Foam.space/token is more about the token sale. Blog.foam.space is more reading. If you're interested in a specific part, there's more than enough text about each area. Developer.foam.space is a description. If you're a developer, you can access our APIs and know more about how to build on the spatial index today. And yeah, this is our Telegram and our mail and our Twitter. Thank you very much.
Perfect. Thanks again. Great.
Okay, so thank you first of all for your talk. It was really, really informative, especially for people who have not followed you yet. I think it's really interesting. And we especially like the proof of location, the dynamic proof of location. First of all, there's a question about the hardware. People are asking how much does it cost? More like €5, 50 or 500?
So that of course demands is based on demand and suppliers. But right now, the Things community approximately estimates €200 per gateway. Of course, with increased demand, potentially that price can be brought down. What we also want to see, and which is our goal with block rewards, is that people that set up these nodes really pretty quickly will see their money made back through basically block rewards, and then later through microtransactions from the entities that move within it.
Cool. Maybe a small question from me for that. So you're talking about the hardware that the validators need. Is there hardware that the user's gonna need? Like, I mean, GPS is available over every mobile phone today. What's about foam?
So that's an important point, that LoRa's in its current state are not in mobile phones, right? So LoRa is one of several competing, what was it called, LoRa ones, LP1s, low power wide area network standards, which is like a radio standard. And they're gonna be integrated with highest likeliness in next gen phones. So what we're basically doing is we're developing a radio agnostic protocol, and we're focusing first on LoRa. But the idea is to be able to integrate different radio standards, and with time potentially also Wi-Fi or Bluetooth, into that standard. But we're working with LoRa first because it has a unique kind of properties by being both permissionless, already having a community around it, and also, it's pretty cool that it goes so far and it's low power. So you don't need that many nodes to set up an environment in an urban area.
Really cool. Another question for that. Is FOM also working on the ocean and underground? People are asking.
On the ocean?
On the ocean, yeah.
No. No, you need ground to deploy it. There are very interesting ideas like low orbit satellites and stuff like that, but we're not focusing on that right now. We think we already have quite an ambitious project ahead of us, and we're focusing on urban environments first, where you can build up a density quickly, and then we want to get people trying this out and building products on it, and then of course you can think about stuff like that. But that's an interesting question.
Another question is main top of industries that would be interested in proof of location. So maybe another question is, in the white paper, you talk about consumers, candidates, and cartographers. Can you give an example of a use case where all of those are involved? So maybe with the industry?
So that's a two-sided question, right? Because the consumers, cartographers, those three categories come from the static proof of location, which is the TCR. And those are like variations of what you normally see in token-curated registries as the groups that act within these environments. We see those, especially within the token-curated registries, and especially initially, we see those as being often the same people. So it's just people that have different interests within the same interface. So initially you will have someone that maybe owns a blockchain co-working space, wants to have that within the map, because most people that will be acting with it, especially initially, will be blockchain enthusiasts, and then also will curate with the existing tokens, and other people will then navigate within it. That's for static proof of location. For dynamic proof of location, we see both people that want to build blockchain products and people that interact with these blockchain products, and enabling a lot of use cases there. And we're not sure what comes out of this yet, because bilaterally signed location, so proof of location, is a pretty new concept. You can have it when you install the hardware yourself. So there's companies that have like Bluetooth devices that they control themselves, and they can run automated processes on that. But what happens when you have decentralized, you have large areas that are influenced by this, and you can have automated processes running on that? That's one target group. And the other one is classical commercial entities that are really struggling with their own solutions to GPS problems today. Uber is having huge problems with it. They're having a team that works with spoofing. So we also see an aggregate demand within those industries for just having proof of location that they can be plugged in. That isn't, doesn't need a DApp around it.
Yeah, I think it's really interesting that we're going to see a lot of use cases we can't even think of right now, probably, because we don't have something like that today. Are there any questions from the audience right now? So maybe we loosen it up a little. Back and back.
Can you just quickly recap what was the current problem with the GPS service?
Sure. So if I didn't explain that clearly enough, that's my bad. Basically, GPS is great, but it doesn't sign. So GPS never publishes where you are, which is maybe good because it's owned by the American state. But basically what we're trying to do is basically create a system where you have local nodes that publish anonymous presence claims. You both know where you are, but they know that someone was there and publish that anonymously, and then you can, at your own will, disclose that to anyone that asks you. And that is not possible with GPS today. So what we do is we kind of combine privacy with the possibility to actually prove where you are. And GPS can't do that. That's the main problem.
Cool. Any other questions? Okay, otherwise we have 2 more questions. Sorry? Okay.
So to repeat the question, because you don't have a mic, how good is the position compared to GPS? So right now we're stress testing based on, well, it depends on the internal clocks of the radios. So we have to do basically see what is the price point, the pain point of price for accuracy. We're hoping that we can get quite good accuracy initially, and then with density get it really good. So we're going to focus on use cases where we maybe supplement GPS that in many cases has really good accuracy today because it's such it's a really good system, but can supplement that claim with a proof of location that maybe is a bit less accurate. And then over time, as we see more demand of the product, we're going to grow the accuracy and then potentially not rely on supplementing anymore.
So you didn't answer the question.
We don't know. Well, so our estimate is around 5 meters.
Okay, another question. Are there any competitors, like people who are doing the same thing that you do?
I think so. There are projects that try to basically create spatial oracles. There are projects that deal with cameras, with camera input or questions. There's a lot of ideas around that. From my knowledge, we're the only one that's developing radio protocol that is doing this. I think our main issue would be more scalability issues with blockchains generally or adoption and stuff like that, more than other competitors.
Okay, cool. And maybe one last question for the ICO. I mean, the token sale is really close, and I guess a lot of people are asking, first of all, what's the valuation of the whole project? And also there's another question who's asking, is it true that there is no code on GitHub for review right now? And will there be a change for that?
Okay, so I'll go through these one by one. What was the first one? The total. So we're selling, we're doing a token sale. So we're doing a bit of a special thing, which basically we're selling a utility token from an American entity, which is, I think we're the first one doing it, which is basically means that anyone can buy them. It's not a security. And we're selling, we don't have a cap in that sense because what we're doing is basically selling 30% of the total tokens. And if all of them get sold, that's an income of $24 million. That will be used for developing the protocol. Another 35% additionally to that is used for mining to incentivize network growth. What was the next question?
Is there no code on GitHub for review? Will some code follow?
So from my understanding, there is code on GitHub. So we have an open GitHub that should be, it's just foam. If you Google foam GitHub, you should find it on foam blockchain GitHub. I think it's F and then minus foam, O minus A minus foam was taken, unfortunately. You should be able to review. I can, if the person asking that question also wants to get in touch, I can follow up with more stuff.
Well, thank you so much. I think if anyone has any more questions, you'll be around for a drink or something. Yeah, everyone is invited to go to the networking area, like back there, talk to each other, make some new friends, and maybe talk to us if you have any questions, or Arthur, or I think Tim is also in the back. Yeah. So yeah, enjoy your evening. Thank you for being here. Thank you, Arthur.